That's true, right? Concentration, molarity, is equal to moles per liter. If I know liters and molarity, what do I know? I know the moles. So what I've just figured out is if I know what concentration was in here, and I know how much of it I had to put in to neutralize this, to make this reaction go to completion, I know how many moles I just dropped, right? If I know how many moles I just dropped, and I know the chemical equation, and I know like it's a 1-to-1 chemical equation, then I know that whatever was in here had to be like, if I dropped in 1 mole, that means down here I had to have reacted 1 mole. So now what? I have a mole. I know how many moles of substance are here, and I knew how much I started with, like 25 milliliters. I would have put in a specific amount of it. Okay? If I know moles and volume, guess what I know? I know concentration. That's how we solve this. That's how we're going to do it. I'm going to rewind one more time, explain that, then I'm going to go through the problem. Okay? All right, here's the bottom line. I'm going to give you let's say I'm going to give you an unknown acid. Okay? Your job, I'm going to tell you what the acid is. Unknown means concentration. I'm going to tell you what the name of the acid is. I'm going to hand it to you, and I'm going to say, use what we have in lab to tell me how strong this, in terms of concentration, this acid is. What is the concentration of this acid? Say it's HCl, a hydrochloric acid. I give it to you. What's the concentration? So you think, I can do this. I'm smart. I know exactly what to do. I'm going to grab this equipment. I'm going to hook it all up. And what I'm going to do is take some of my unknown solution that I don't know how concentrated it is, but I do know what it is, and I will put it in here. I know that it's, let's say, HCl. Okay? Now, I need to know what I'm solving for is the concentration of this, right? So to do that, what 2 things will I need to know? I need the moles and the volume. Now, one of those I can't figure out right now. One of them I can control. What can I control? The volume. So let's say I put in 25 milliliters. Now I've got volume. I've controlled that. So I put in 25 milliliters of HCl right in here. Okay? Now, I know volume. I don't know concentration because I can't solve it until I have moles. Now, where am I going to get this moles from? I'm going to use stoichiometry. I'm going to use the reaction that I know. So what I'm giving you then to work with is, let's say, 0.3 molar sodium hydroxide. I say, I guarantee you that this is 0.300 molar to 3 significant digits. It's highly specific. Here's what you have. You know the concentration. Okay, you know that I'm putting in sodium hydroxide, and it's going to be 0.300 molar, we'll say. Okay? Now, here's what we need. Bottom line is, if we're going to figure out something based on stoichiometry, in other words, let a reaction go and see how much of it reacted and how much stuff formed, that kind of stuff, what unit do we have to deal with? Nope. What is the only unit that we can use when manipulating a chemical equation? Moles. That's it. So we have to, our communication between what's in here and what's down here has to be through the unit of moles. So that's our key. Okay, that's our connection between these two situations. All right. Now, we've got sodium hydroxide. We've got we know its concentration is 0.300 molar. Now, depending on how much volume we end up putting in determines the concentration, or determines, the number of moles, right? Because if I have 25 milliliters of 0.300 molar, and I have 25 liters of 0.300 molar, that's 2 different amounts of moles, right? The one with liters has a whole lot more moles than the other one. So what I'm trying to figure out is how many moles come in here. So here's what I do. I set this up. Here I've got 25 milliliters of an unknown concentration of HCl. Moles is the key. That's what I'm trying to get to. Up here I've got 0.300 molar sodium hydroxide I'm putting in there. Here's what I have to do. I know that if I mix sodium hydroxide and hydrochloric acid together, what am I going to get, chemically speaking? What 2 species am I going to get? I'm going to get salt water and water, salt water, right? I'm going to neutralize that. If I take all the acid and react it with all the base and nothing's left over, I'm going to have nothing but salt water left behind. That's the key. That's what we're trying to watch happen. So the way that we're going to do this is put a couple drops of, let's say, phenolphthalein. It's an indicator. You don't need to know that. Okay, I'll just put a couple drops of indicator in here. And the indicator tells you that when it changes color and stays that way, neutralization has been achieved. Okay, so I'll put a couple drops in here and let it sit around, and it shouldn't change color. It should be clear. Okay, all right, so I turn this knob and let some sodium hydroxide fall in. But I'm careful. I don't want to do it too much because I don't want to overshoot it. I turn a little bit more. Then I go about 1 milliliter at a time. All of a sudden, I see flashes of pink down here. Flashes of pink indicate I'm getting close to the neutralization point. So I let it go a little bit more. I let it go a little bit more, and it's starting to hang around a little bit more, so I do 1 drop at a time. I do 1 drop swirl, 1 drop swirl, until at some point, what's going to happen is this is going to stay a very faint pink. It's not going to be clear anymore. At which case, I can assume that neutralization has been achieved. So, what does that tell us? When neutralization has been achieved, that means I have correctly reacted all of everything that was in here. Okay? I've reacted all of the acid that was present. There's no more acid left to react in that particular case. So what I've got to figure is, if all of the acid has reacted, how much base did I use, basically, in terms of moles to react all of that? So I look, and if my level was up here, and now it's way down here, I see how many milliliters of it I used. Okay? This is thoughtful. You got to think it through. I see how many milliliters of it I used. If I know how many milliliters of it I used, and I know the concentration of that which I used, guess what I can find? I can find, well, the moles. I can find the number of moles. Now, if I know how many moles I just dropped in here, and I know that whatever that number is means that the reaction was complete. In the case of my particular chemical reaction here, which was this, HCl plus NaOH gives me NaCl plus H2O, right? Balance that. It's already balanced. It's a 1-to-1 ratio. So that means for every 1 mole of this that I dropped in here, it reacted with every 1 mole down here. So if I know, vice versa, it goes the other way too. So once I know how many moles I dropped down, I know how many are down here. Once I know how many are down here, I just take the moles divided by the volume, which I controlled myself. I've got molarity. Okay? Now you might be able to follow that when I said it. Going on your own is a different story. But you've got to be able to do this. This is going to be a problem that you're going to see. Okay. Now, once this reaction is complete and when we reach neutralization, this is what we're going to call the end point of the titration. Okay? So there's the drops being added, I guess. There it goes, very slow motion, and so on. Okay. Okay. So if you were looking at it in the actual lab, this is what you would see. Notice I said you see these flashes of pink, right? You stir it around, it disappears until eventually this faint pink persists, and you can't get rid of it. Then you can assume that neutralization has achieved. Huh? Yeah, in one of your neutralization reactions, I had you use phenolphthalein as an indicator. It's also, remember that demo I did at the very beginning of class with the turning of pink? That was an ammonia reaction with phenolphthalein. Phenolphthalein, see the reason that works is phenolphthalein is clear in an acidic solution, and as soon as the solution tips and becomes extra in terms of hydroxides, the second that it becomes basic, it reacts and turns pink. Okay? So you're adding, remember you're adding base. Here's an acid solution. There's lots of hydrogens around. The more you add, the more it gets full, and those hydroxides, when they come in, instead of reacting with phenolphthalein, they react with the hydrogens and form water. But there comes a point when all that is saturated, and then when you drop in hydroxide, it doesn't get absorbed. It doesn't react with hydrogen anymore. It just stays there floating around. When that happens, then the phenolphthalein will react with it and turn it pink. That's how we know the end point is reached. So there you go. We're bringing in this hydroxide. And you'll see that here's the beginning. We've got acid solution down here. As this hydroxide falls in, notice that it's reacting with some of those hydrogens to form water to help neutralize some of those hydrogens.